Hey there, and welcome to AP Calculus. This is section 4.2, 4.3, Homework Solutions video from page 283. We're going to go through these problems right here. I was able to get the first four on the board here. So number 5, we're integrating from 0 to 1 of 2x dx. The antiderivative of 2x would be x squared. You can check it by taking the derivative. And we're evaluating that from 0 to 1. So we do our vertical line 0 to 1. And we plug 1 into x squared and then subtract out 0 squared. Okay, so that's just going to be 1. All right, number 9, we're integrating from -1 to 1 of t squared minus 2 dt. Okay, so the antiderivative of t squared would be 1/3 t cubed. And then the antiderivative of 2 is 2t. Don't accidentally make that 0. Students will take the antiderivative and then take the derivative on the second term, but no, 2t. Then we plug in 1, so that's 1/3 times 1 cubed minus 2 times 1, and then subtract out plugging in -1 into that. And I like to put brackets around it so I don't mess up the signs. So we would have 1/3 times -1 cubed minus 2 times -1. All right, that's 1/3 minus 2 minus, and I left the brackets in place. -1 cubed is -1, so minus -1/3, and then minus 2 times -1 would be plus 2. 1/3 minus 2 is -5/3. And then we would have a or a positive 5/3 in the bracket. So -5/3 minus 5/3 would be -10/3. So there's a lot to keep track with in your head there. So just be careful, take your time, double check, and you can get it. All right, number 13, we're going from 1 to 2 of 3 over x squared minus 1 dx. I'm going to rewrite that as 3 over x squared is 3x to the minus 2, and then minus 1. So the antiderivative of 3x to the minus 2, we add 1 to the exponent, -1, and then I need a negative sign out front. So when you take the derivative to check, -1 times 3 would be 3, and then subtract 1 from the exponent would be -2. And then the antiderivative of 1 is x. Okay, I'm going to rewrite now that -3 over -3x to the minus 1. I'm going to come down here and write that as -3 over x because that's easier for me to process in my head. So minus x from 1 to 2. All right, plug in a 2. I'd have -3/2 minus 2 minus, and then let's put this in parentheses or brackets. Plug in 1. -3 over 1 minus 1. So -3/2 minus 2, that's like -3/2 minus 4/2. That'd be -7/2. And then -3 minus 1 is -4, but the negative out front would make it +4. So that's -7/2 plus 8/2, which would leave you 1/2. All right, number 17, I'm going from -1 to 1 of t to the 1/3 minus 2. So the antiderivative of t to the 1/3 would be add 1 to the exponent, that's t to the 4/3, but I need a 3/4 out front. Okay, always check by taking the derivative. So then minus 2t to make sure you get back to the original function. Okay, we're going to plug in 1. So it's 3/4 times 1 to the 4/3 minus 2 times 1 minus, and then make sure to bracket it, 3/4 times -1 to the 4/3 minus 2 times -1. So that's going to be 3/4 minus 2 minus, okay, -1. If you can take the cube root of that, and that's still -1, but anything to an even power would make it positive. So 3/4 times +1 is 3/4. Then negative makes +2. So 3/4 minus, and that would be 8/4, right? So that's -5/4. And then in brackets here, that'd be 3/4 plus 8/4, which would be 11/4. So -5/4 minus 11/4 is -16/4. So you're getting good with your fractions here on all this. That's a good exercise, all right, to go through all that in your head and get good at doing fractions again if it's been a while. And that would be -4. It's a lot of just good old-fashioned middle school math and even elementary school math in calculus. All right, now let's go to 25. Okay, so 25, we are integrating from 0 to pi of 1 plus sine x dx. Okay, that's going to be the antiderivative of 1 is x, and then the antiderivative of sine x would be minus cosine x. Let me take the derivative in my head real quick, but the derivative of cosine is minus sine, so minus minus would make that a plus there. We're going from 0 to pi. So that's going to be pi minus cosine pi minus, let's put a bracket, 0, plugging in 0, minus cosine of 0. That's going to be pi. The cosine of pi is -1 if you want to have your unit circle out, minus the cosine of 0. So 0 minus 1. So minus -1. 0, cosine of 0 is 1. So that's going to be pi plus 1 plus another 1. So that is pi plus 2. All right. Got to be careful with all those negative signs. 27, negative pi over 6 to pi over 6 of secant squared dx. Okay, the antiderivative of secant squared is tangent x. We're evaluating that from negative pi over 6 to pi over 6. So that would be the tangent of pi over 6 minus the tangent of negative pi over 6. Now on your unit circle you don't have a tangent, but you know that tangent of pi over 6 is equal to the sine of pi over 6 over the cosine of pi over 6. Okay, that's going to be 1/2. So look at you get the unit circle on the test, over the square root of 3 over 2. That's 1/2 times, flip and multiply, 2 over root 3. So that would be, the 2's cancel, and you'd have 1 over root 3. Negative pi over 6 is in the 4th quadrant, so it would be the same as 11 pi over 6, and there your sign is negative. So negative tangent of negative pi over 6 would be -1 over root 3. Okay, so what we have here is 1, we're plugging in here, so I'm going to go ahead and erase all this scratch work here. And you would have 1 over root 3 minus -1 over root 3, which is going to be 2 over root 3. The back of the book may have rationalized that, multiplied by root 3 over root 3, and that would be 2 root 3 over 3, but I don't care if you do that. That is fine. Okay, 29. So 29, we're going from negative pi over 3 to pi over 3 of 4 secant theta tangent theta d theta. All right, the antiderivative of secant tangent is just secant. So this is going to be 4 secant theta evaluated from negative pi over 3. Now you don't put a plus. These are definite integrals. You know, we've got numbers here. You don't put a plus c. Okay, so this is going to end up being 4 times the secant of pi over 3 minus 4 times the secant of negative pi over 3. Okay, the cosine of pi over 3 is a half. You flip that to get the secant of pi over 3, which would be 2. Negative pi over 3 is the same. It's in the fourth quadrant. You're just going the opposite direction. Okay, instead of you'd be going clockwise, and that's the same as 5 pi over 3. Okay, so the cosine's positive in the fourth quadrant, so it's also going to be 2. So it's just 8 minus 8, which is 0. Okay, let's see if we can fit 31 on here. So 31's a word problem. It says a company purchases a new machine for which the rate of depreciation is 10,000 times t minus 6 between 0 and 5, where v is the value of the machine after t years. Set up and evaluate the definite integral that yields the total loss of value of the machine over the first 3 years. So they're saying this equation works for the loss in value of this machine between 0 and 5 years. But we're only evaluating the first 3 years. So we would integrate from 0 to 3 of 10,000. I'm going to go ahead and distribute that t minus 6. 10,000 t minus 60,000. All right, all I did was go ahead and distribute the 10,000 across the t minus 6. So the antiderivative of that, of course, for the t, you make it t squared, and you would have a 5,000 out front, right? 2 times 5,000 would be 10,000. And then minus 60,000 t. We're going to evaluate that from 0 to 3. Okay, if you're not sure, take the derivative. Okay, so this is going to be 5,000 times 3 squared minus 60,000 times 3. And then when you plug in a 0, they both terms have a t. You plug in a 0, you're going to get 0, so just minus 0. So we love zeros. So that's 9 times 5, 45,000 minus 180,000. So that would be negative 135,000. So what that's saying is the machine just over time depreciated or lost a value of 135,000 during those 3 years. All right, looks fancy, but really is easier than a lot of the problems we've worked so far. The antiderivative wasn't hard at all there. Seems like I work that problem every year because students just kind of freeze up when they see a word problem. Remember, we're in the antiderivative chapter, so anything you see, you're probably going to be taking an antiderivative. All right, number 33. So when you find the area under a curve, you're just integrating. We're integrating from 0 to 1 of that function, x minus x squared. And that'll give us the area under the curve. So that's going to be 1/2 x squared minus 1/3 x cubed. And we're going to evaluate that from 0 to 1. And when we plug the 0 in, we're going to get 0, so that's cool. So this is 1/2 times 1 squared, which is just 1/2, minus 1/3 times 1 cubed, which is just 1/3. So 1/2 minus 1/3 is 1/6. So the area of that region is 1/6, and we don't know what the unit is. All right, 35. Okay, we are doing 3 minus x, so we're integrating from 0 to 3 of 3 minus x times the square root of x. Okay, that's going to be 0 to 3. I'm going to rewrite this as 3 root x. Now, I probably, if I was doing this homework, wouldn't show this step. And then minus x root x. I'm just distributing that root x. But I'm showing all this for illustrative purposes. So that's 3x to the 1/2, right? And then x to the 1 times x to the 1/2. 1 plus 1/2 would be minus x to the 3/2. Okay, now we can take the antiderivative. Okay, add 1 to the exponent, that'd be 3/2. And I would need a 2 out front, because 3/2 times 2 would give me 3. Minus x to the 5/2, and I would need a 2/5 out front. So that would give me x when I brought the 5/2 down, and then x to the 3/2. And we're going 0 to 3, and I'm glad we got a 0 here because I only have to worry about the first part of this. So that's going to be 2 times 3 to the 3/2 minus 2/5 times 3 to the 5/2. All right, so 3/2, that's going to be the square root of 3 cubed. Okay, so the square root of 3 times the square root of 3 times the square root of 3. So that's going to be 3 root 3. So 2 times 3 root 3 minus, and then the square root of 3 to the 5th power, root 3 times root 3 times root 3 times root 3 times root 3. That's going to be 3 times 3, which is 9. So that'd be 9 root 3. So 2/5 times 9 root 3. Wow. So that's 6 root 3 minus 18 over 5 root 3. Okay, so that's 30 over 5 root 3 minus 18 over 5 root 3. Okay, so 30, that'd be equal to 12 over 5 root 3. Wow. What a pain in the butt. But that is the right answer. If you do that decimal, it's about 4.15. Hey, that's a good exercise, though, to remember how to deal with radicals. You probably haven't done that, since early in pre-cal, if you were in my class. So it's been a while. All right. 37. We're finding the area from 0 to pi over 2 of cosine x. All right, this is easy. So that's the antiderivative of cosine would be sine x. 0 to pi over 2, that's going to be the sine of pi over 2 minus the sine of 0. The sine of pi over 2 is 1. So that's 1 minus sine of 0 is 0. 1. That's a breath of fresh air compared to number 35, isn't it? All right, and finally number 62. So 62, the bottom, the volume V in liters of air in the lungs during a 5-second respiratory cycle is approximated by the model. V equals 0.1729 t plus 0.1522 t squared minus 0.0374 t cubed, where t is the time in seconds. Approximate the average volume of air in the lungs during one cycle. So remember, we're going to use the formula to get the average of 1 over b minus a, integrate from a to b of the function. And the function is that fancy decimal function there. So it's 5 seconds. So that's going to be 1 over 5 minus 0. We start with 0 seconds. 0 to 5 of that function, the volume function, 0.1729 t. Plus 0.1522 t squared minus 0.0374 t cubed. All right, looks terrible, but it's not bad. So that's going to be, first we're going to get this. You've got a 1/5 out front. And let's get the antiderivative. Well, the t is going to be squared. So it's going to end up being 0.1729 t squared, and then you divide by the exponent that you raised it to. Because when you bring it down, the 2's will cancel and you get back to this. All right, and then what's this square? That second one is squared. All right, and then plus 0.1522 t cubed over 3 minus 0.0374 t to the 4th over 4. So, you know, I like to when we don't have these decimals out front, I like to think about it, okay, what fraction do I need to put out front in order when I bring the exponent down, it will cancel, right? Well, in this case, it's hard to think of in that way, but just remember, you just divide by the exponent that you raised it to, and that will do the same thing. And then we're going to evaluate this from 0 to 5, and then do the whole thing times a 5th. So that's going to be 1/5 times 0.1729 times 5 squared over 2 plus 0.1522 times 5 cubed over 3. And this would be easy to mess up in your calculator. Minus 0.0374 times 5 to the 4th. We're going to plug in 5 over 4. And then I don't have to subtract anything out because there's a t in all of these, and so it's going to, when I plug a 0, it's going to, if it had been 1 to 5, then I would have had to do the whole thing again, but plug in 1, right? Okay, if you get all that in your calculator and things don't go awry, in fact, I'm going to give you the numbers here in case you can't figure out where you messed up. It's 2.16 plus 6.34 for this second term, and then minus 5.84. All right, and that's 0.53 liters. So that's the average amount of air in the lungs. That kind of makes sense. A half a liter of air in the lungs on average during your respiratory cycle. Okay, that does it for this homework solution video, and I will talk to you next time.